Okay, Wildcats. Today we're looking at Journal page 70, Introduction to Regression. Regression inspire steps. Step 1, press the On button. Step 2, select one new document. Step 3, select No when asked, do you want to save unsaved document? Step 4, add lists and spreadsheets. Step 5, complete the table. Step 6, move the blue box to C1. Step 7, press Menu for Statistics. Number 1, Stat Calculations. Step 8, choose a function. Either 3 linear, 6 quadratic, or A exponential. Step 9, X list X and Y list Y. Step 10, press enter and check the R value for linear or exponential and the R squared for a quadratic. Step 11, choose the function to model that is closest to 1 or negative 1. If you would, go ahead and finish up your notes. All right, now your notes are completed. Let's take a look at the examples. All right. Find the function that models the data when the function is either linear, quadratic, or exponential. So let's take a look. Okay. So the first thing we're going to do is we're going to grab a calculator and go to New Document, No. We're going to go to Add Lists and Spreadsheets. Okay. X, Y, and then you're going to type in 12. Oh, now this is a mistake that you don't want to make. If I press 12 here, it's going to make everything in this column 12. We don't want to do that. So we're going to delete this. Go down. Never ever put anything in these two blue boxes. Okay. So that's 12, 16, 20, 24, 28. And then 0.8, 3.6, 16.2, 72.9, 328.05. Okay, now we're going to move up to C1 and press Menu, Statistics, Stat Calculation, and then we're going to do the first one. Let's do linear. Okay, so then that would be, and we want the mx plus b1, so number 3. Press enter. X, Y, press enter twice. Now we're going to go down to the R value, which in this case is 0.821. Okay, but that's a lot of numbers. Let's really trim it down to just one decimal place. So let's just make that 0.8. Actually, in this case, let's go to 2 decimal places for today. Okay, now we're going to go up to F1 and we're going to press Menu, Statistics, Stat Calculation, and then we want Quadratic Regression. Press enter. X, Y, press enter. And again, in this case, we want R squared. So R squared is 0.95. Okay. Now we're going to go to I1 and press Menu, Statistics, Stat Calculation, sorry. And in this case, we want exponential. X, Y, press enter twice. And then we want to go to the R value, which in this case is 1. So in this case, the R was 1 for exponential, so we're saying that this is an exponential equation. So you want to circle exponential. And then we want to write the equation down. Now we know for exponential, it's y equals a times b to the x. Okay, so we need to know what A and B are. Okay, so A, we use our calculator. Went way too dark. Oh, got turned on, that helps. All right, so our A value in this case is 0.009. So let's round that to 0.01. Okay, and then B equals 1.46. So then our equation is y equals 0.01 times 1.46 to the x power. Okay. All right. Now let's take a look at example 2. Okay. So same thing. We're going to go to new document, no, add list and spreadsheets, and then we're going to do x, y, 13, 19, 25, 31, 37, 43, and then -1, 17, 35, 50, 53, 71, and 89. Okay, I'm going to move our cursor up to C1, menu, statistics, stat calculation, and we want to do linear regression first. Okay, so that's number 3. X, Y, and then we want the R value, which in this case is 1.00. So far we think this is linear regression, okay? But let's check quadratic. So then we're going to go to F1, menu, statistics, stat calculations. And what you didn't see in the last one is I actually just pressed the number 3, but that's what we got there, okay? But now we're going to go to quadratic regression, which is number 6 for there. Okay, X, Y, press enter. And we're going to go to the R squared value. Well, this is 1.00. So it could be quadratic as well. Let's take a look at exponential. Okay, so menu, statistics, stat calculations. In this case, we want exponential, X, Y. Now, you get domain error, so you can actually just write error. Okay, so it's definitely not exponential. Okay? So now, when you get both linear and quadratic, let's go to the quadratic first, okay? So the quadratic equation we know is y equals ax squared plus bx plus c. So a equals, it looks like 0, b equals 1. Oh, no, where did I get 1? I'm sorry, b equals 3, and c equals -40. So our equation is y equals 0x squared plus 3x minus 40, which in essence we have y equals 3x minus 40. Oh, check the lighting and adjust the camera a little bit. So really this is not quadratic, it's linear. So you want to be careful when you get one for both. You want to check the quadratic and you'll see usually it's either quadratic or will lead to linear. Okay, so this is a linear regression. Okay. All right, let's take a look at example 3. All right, so we're going to go to on, new document, no, add list and spreadsheets, x, y, 2, 7, 12, 17, 22, -100, negative 55, 40, 185, 380. Okay, now we're going to go up to C1, menu, statistics, stat calculations, and we want linear regression, X, Y, and we want to go to the R value, which is 0.97. Okay, so now we're going to go to the right, go up to here, menu, statistics, stat calculation, and then we want quadratic regression, X, Y, and we see the R squared value is 1. Okay, now let's try exponential. So menu, statistics, stat calculation, exponential regression, X, Y, enter, and you see here you get an error. Okay, and the sun came out, so we got to do some camera right there. All right, so now we see here it's quadratic. And while I'm thinking about it, I wrote linear here and exponential here, but really I'm going to erase those because you really don't need to write them. Because all you have to do is circle. This is exponential, there's the equation, this is linear. So, okay, so this is quadratic, so we don't need to write quadratic. But we do need to write down the equation, which is y equals ax squared plus bx plus c. And then we need to know what a, b, and c are. So a equals, b equals, and c equals. And let's go back to our calculator. So let's go back to quadratic. Okay, so a is 1, b is 0, and c is negative 104. Okay, so our equation is y equals 1x squared plus 0x minus 104. Okay, go ahead and finish up example 3. All right, let's take a look at example 4. So on new document, no, add list in spreadsheets, x, y, negative 6, 1, 8, 15, 22, 15, 1, 30.12, 102.36, 217.72. Okay. And then we're going to do linear first. So menu, statistics, stat calculations, linear regression, X, Y, press enter. And then we're looking for the R value, which in this case is 0.89. Okay. So we're going to click to the right, come up here, and then menu, statistics, stat calculation, and then we want quadratic regression, X, Y, press enter, go down to the R squared value, which is 1.00, okay, and then we're going to click to the, go here, menu, statistics, stat calculation, and then we want to go to exponential regression, X, Y, and then it looks like the R value is 0.76 because the 8 increases to 5 to 6, okay? So here we can see that this is quadratic regression. So we know the equation for quadratic is y equals ax squared plus bx plus c. And we need to know what a is, a, b, and c. So let me go back here to quadratic regression. So it's a is 0.44, b is 0.2, and c is 0.36. So your equation is y equals 0.44x squared plus 0.2x plus 0.36. All right, if you would, go and finish up example 4. All right, now, because of the way the calendar is, I'm going to have you do journal page 70 and 71, okay, today. So what I want you to do is you're going to put this in your journal, okay? Now, what I would like you to do is pause your video, complete Introduction to Regression, okay? And then you're going to turn it in. Then you're going to unpause, and then you're going to start the video and complete Modern Real World Data, journal page 71, okay? All right, so if you're watching now, I assume you've paused, you completed journal page 70's assignment. Now let's start journal page 71. All right, now, it says find the function that models the data, write the function that models the data, then predict. The table shows the population growth of the Temple wildcat population, okay? So what we're going to do is we're going to find linear, quadratic, and exponential, so we're going to use a calculator for that, okay? And you have your paper in front of you so you can get the points. But new document, no, add list and spreadsheets, okay? X, Y, 1, 6, 11, 16, 21, move there, 26, and 31. Okay? And then that's 662, 740, 825, 908, see, 103. All right, so those are those values from your table, okay? All right, now we're going to go to menu, statistics, stat calculation, linear regression, X, Y, press enter. And we want to go to the R value, which is 0.999, which that rounds up to 1. So we would just say that's 1.00. Okay. Now let's go to quadratic. Okay, menu, statistics, stat calculation, quadratic, X, Y, enter, enter. And we want the R squared value, which is 1.00. And let's do exponential. So menu, statistics, stat calculation, exponential, X, Y, enter, enter. And the R value is 1.00. Okay. Now, and I did this on purpose because sometimes this will happen, but you have to understand the data, what's going on. Okay. When you're talking about population growth, it's exponential. Okay, and the sun came out again. That crazy sun. All right. Although it can't be too hard on the sun because it is a star. All right, now, it says write a function that models data. Well, we know that this is exponential. So the equation is y equals a times b to the x power. Okay, so we need to know what a and b are. So a equals and b equals. Okay, so let's go back to our calculator. So we know exponential. So looks like a is 657 and b is 1.02. Okay, so A is 657 and B is 1.02. So your equation is y equals 657 times 1.02 to the x. Okay. Now it says use your model to predict the population in 2020. Okay. So what we have to do is we need to take 2020 and subtract 1974 because we're trying to find the years after 1974. Okay. So 2020 minus 1974 is 46. So this 2020 is 46 years after 2020. Okay. So now that we have 46, we're going to plug that in for x. So x equals 46. So we have y equals 657 times 1.02 to the 46 power, which when we plug that into calculator, y equals, let's find that out. Okay. So we're going to go to on, new document, no, add calculator. I'm going to type in 657, parentheses 1.02, key to the 46 power. Now, if this happens on your calculator, you get the E, that means one of my Matthew students is using a calculator. So we want to press on, go to settings, document settings, and we need to go to restore default, press OK. And then we need to go to make default, press OK. Now we go back to current, I'm going to highlight, enter, and we can see that Y is 1633.7. But since we're talking about population of wildcats, we just say that that is 1633. Okay? All right, now you always want to complete the problem with the sentence. So we want to say the wildcat population will be 1,633 in 2020. Which, if you get a chance, they have the Wildcat Refuge, where they actually keep all the lost wildcats in Temple that haven't been adopted. Just check it out. It's near the animal shelter for dogs and cats, but they have a special one for wildcats, so you should check it out. All right, so go ahead and finish that up. All right, now let's take a look at example 2. Okay, the table below lists the total estimated number of wildcat blue cases by year of diagnosis from 1999 to 2003 in Temple, Texas. Wildcat blue is when you turn blue from overexposure to wildcat skull spirit. Okay, so same thing, we're going to use our calculator. So I'm going to go on, new document, no. Oh, got to do it again, new document, add list and spreadsheets, X, Y. So we're going to type in 1999. But wait, that's not going to work. So what we have to do is we have to change these numbers. So 1999 is going to be year 0. Okay, 2000 will be year 1. 2001 will be year 2. 2002 will be year 3, and 2003 will be year 4. Okay, so that's what we're going to plug in. So that's going to be 0, 1, 2, 3, 4, and then 41,356. 41,000. Don't put the comma in. 267. 40,833. Lots of wildcat blue cases apparently. 289. Oh, I made a mistake somewhere, and that happens sometimes. So what I did was I didn't go up high enough to 0. So you just have to retype it in. So that's 41356, 41267, 40833, 41289, and then 43171. Okay. And we're going to go to menu, statistics, stat calculation. And then we want to do linear first. Okay, x, y. Okay, and then we want to go to the r value, which is 0.63. So 0.63. Now we're going to go to the right, go to menu, statistics, stat calculation. Now we want quadratic regression. X, y, enter, enter. And then we want the r squared value, which in this case is 0.90. Okay, so it's looking like it's quadratic, but let's try the exponential. Okay, so menu, statistics, stat calculation, and then exponential, x, y. And it looks like the r value is 0.63. Okay, so it's obvious that it's a quadratic regression. Okay, so we need to find the function. So we know this quadratic. Okay, so then that's y equals ax squared plus bx plus c. So we need to know what a, b, and c are. So a, b, c. Now let's go back to our calculator. Okay, so we're going to go to current. We're going to go back to quadratic. So here we have our a value is 345.14. B is negative, it's a big number, let me use space, negative 1015.37. And then C is 41,543.1. Guess we'll have to steal some space from this part of the problem. Okay, so our equation is y equals 345.14x squared minus 1015.37x plus 41,543.1. Okay. All right, now it says use it to predict the number of cases in 2016. Well, if 2003 is 4, then 2004 would be 5. Okay. And let's actually change this to 2016 is already passed. Let's change this to 2020. All right, now if 1999 is 0, then if we take 2020 minus 1999, then that will tell us the number in the table needs to be, okay? So let's calculate that. 2020 minus 1999 is 21, so that'd be year 21, okay? So we're saying x equals 21. So we need to plug 21 in for x here. So let's do that in a calculator, okay? And disconnect a little bit. That crazy sun just throws off everything in the video, doesn't it? All right, so we're going to type in 345.14 parentheses 21 squared minus 1015.37 times 21 plus 1,543.1. And we see that y equals, wow, that's a lot of blue cases. That's going to be 172,427. So I think all of Temple and even parts of Belton will have the blue, Wildcat blue. Okay, so you want to close with a sentence. So we're going to say that there will be 1,700 to 427,000 blue cases in 2020. Okay, go ahead and finish up your examples and then start working on the assignment and have a wonderful Wildcat day.